Okay, let's go back to our drawing example one more time. Okay, so let's remove all of them. Okay, so let's define, well, in this case we are going to use template for operations, not the data types. You can use templates for we can use template to define operations of your class. It's gonna be interesting. So geometric object maybe. Okay. So we can define a draw class. So public void do something. In this case, draw. Okay? And maybe you'd like to define move class. So move maybe. And do. So this class defines an operation, draw. This class defines an operation, move, right? So we can use template class T operation, maybe. Operation dot do something. It looks weird, I know. It looks weird. So let's see how it works. So geometric object. This is class draw. This is a class draw, right? So draw object, and do something. And we can repeat the same thing with move class. So we can move. Okay, let's compile. What's wrong? Draw object. Okay. Draw object, move object, maybe. Right? So let's execute it. So you can draw or move in one interface. It's interesting. So what happens inside is that, well, if you call this one, it's going to call something like draw do something. Okay, and if this T operation is move, then it's going to call like this one. But you need an instance here. Okay, so this is an interesting approach to template classes, and actually this is what happens inside the game engine or something. Some other applications. And maybe you want to use polymorphism for this one, right? You want to use just one for loop here. One for loop, right? This is what we want as a good C++ programmer. So in this case, you can define an interface of all of these operations. So class geometric object interface and public void do something. In this case, let's try virtual function, and well, let's try with pure virtual function or ptr 0. Okay, so actually we are going to study function pointer next week. Okay, so let's dig inside a little bit inside about this one next week. Okay, so and we can inherit this interface here. So and I like to use standard library as maybe vector, and I heard that the STL library is standard template library. The name was wrong. I have thought that it's standard ST library, but the name was wrong. It's standard template library. Okay, so you are going to see it one more time. So std vector and geometric object interface pointer here. So now you know what this means. This is for template. You want to reuse this vector class for all the other data types. That's why we use STL library. Okay, so obj list here. Okay, so let's try the same thing we did for polymorphism. Try new. What's wrong? Do some. Okay, there was a typo. There was a typo here. Okay, there was a typo. Something, right? So something. Okay, so we are okay now. Okay, right? And let's push back one more templatized class here. Okay, and use modern C++ grammar object like dot do something. What's wrong? Okay, we need arrow here. Okay, so this one here, this one here. So we combined template programming and polymorphism. It's very useful. So you don't need to, in some cases you need to implement many of children classes. It's true. You need to define some operations. But well, if you start combining those children classes, then well, you can simply use templatized more general or generic children class. Oh, child class, I mean.